All right, good morning, my beautiful followers, and welcome to today's class. In today's class, we're going to be talking about a very important electrical device, the phase failure device. This device is one of the most important protection devices for three-phase machines. So what this does is that it disconnects the power that goes to this machine whenever any or two of these phases fails. Because these electric machines are designed to operate only on three-phase, and anything less than that could cause a serious damage to either the device or the electrical installation, or both. So what we do with this guy is to protect those electrical machines from damage due to phase failure. And today, I want to demystify this and tell you exactly what is inside, so that even in the absence of this, you can build your own phase failure device and use it to protect your machines comfortably. So for some of us who are a bit knowledgeable in digital electronics, this phase failure is designed just like a 3-input AND gate. We have what we call gates in digital electronics, and it is something like this. It has this symbol. I'm not a good artist, but this is what it looks like. All right. This is our 3-input AND gate. Here we have our L1, L2, L3, and this is our output. What happens here is that there is going to be an output only when all these phases are complete. All right. In what we call a truth table, we'll have something that looks like this. Sorry, I'm going to bore you with a lot of explanation today. L1, L2, L3. So these are our inputs. 1, 2, 3, 4. 1, 2, 3, 4. So we're going to arrange these our inputs in this manner. These are inputs from different phases, okay? And this is our output. We are going to have... So what this means is that we can only have output here when all these inputs are 1. 1 means on, 0 means off, okay? So here we don't have all of them, so we have 0. Here we don't have all of them, 0. We don't have all of them here, 0, 0, 0, 0, 0. Here we have all of them complete, 1. So what that means is that in a phase failure device like this, you can only have an output when all the three phases are all on. All right. So when any or all of them are off, you are going to have off as your output. Okay. So now I'm going to represent this, making use of these 3 relays. And to do that, let me show you again in a simple drawing. Let me turn this over. All right. So what we have here right now is this is going to be the symbol of our first relay, the relay coil. This is how we do it. And the third one is like this. Okay, and then here we're going to have the contacts of our relay. We're going to have this one here. We're going to have this one here. All right. So what happens here is that all these relays must be on before we have an output to power our motor. So in this particular relay here, it takes its power from L1. This particular one takes its own power from L2, while this one takes its own power from L3. Of course, to complete this circuit, we're going to connect this one to this one, and this one to this one, and then all of them to neutral. All right. So when we have power on L1, this one will close. When we have power on L2, this one will close. And when we have power on L1, this one will close. All right. Now, to drive the electric motor, we need a contactor. All right. And then, of course, we're going to be also needing an overload relay, which is this one. We're not going to talk about this overload relay today, but just for you to know. Now, we're going to drive this contactor to power our motor. Now, to do that, let us just do another symbol for our contactor here. Remember, we have our A1 and A2. And then the 3 phase for the motor, we're going to have them like this. Sorry, this is just for illustration. Okay, so normally, we're going to take the first terminal of our relay coil, call it A1, to any of these phases, all right? Normally, I choose L1 for my contactor coil. So I can take my L1 from here all the way to A1, all right? This is where I connect it. Now, for this contactor to close and power the motor we have here, all right, this one must be connected to neutral. And for us to do that, we're going to connect this neutral from here to this terminal of our relay. And then we're going to connect this one to this terminal of our relay. And we're going to connect this one to this terminal of our relay. And we're going to take this one all the way to this A2. So what that means is that if power fails here, this one will open and this one will be disconnected. If power fails here, this one will open and this one will be disconnected. And if power fails here, this one will open and this one will be disconnected. And if you have power here, this is closed. If you have power here, this is closed. If you have power here, this is closed. And this neutral will go all the way to energize our contactor. All right. So as I explained before, in a phase failure device or relay, if power fails in any of them, this contactor will be de-energized. So this is exactly what we have here. So if you don't have this, you can build this. So the next thing we're going to do now is to do our wiring. So the first thing to do is we're going to mount our rail. Okay. So we'll mount our rail. All right. So when we are done with this rail, the next thing to do is to mount the base for our relays. We're going to still make use of this our popular base. Mount the first one, mount the second one, mount the third one. All right. Remember, we're still going to make use of our power source. Our power source remains our power source. Okay. I'm trying to adjust this so that it can cover everywhere. Okay. So the next thing is we need this set of contacts. We'll be needing this set of contacts. Mount the first one, mount the second one, and then of course our contactor. Mount our contactor. All right. So the first thing to do is that we are going to connect power to the first relay, and that first one is this one. So we're going to slack out on pin 7. You remember pin 7 and pin 2 are for the coil of our relay. So I'm going to drag this through here, and then it's going to come to L1, this breaker. Okay, slide this out and close it. All right, and then we take the next one. This one can do that job very well. So we're going to insert it here on pin 7, and then we can also pass it through here all the way to L2. And then the next one, I'm going to take this one, pass it through here, insert it on pin 7 and lock it. We'll lock it. We can still pass it through here to L3 breaker. All right. So this is what we have. So what we're going to do now is to connect our neutral lines. We're going to be making use of pin 2 for neutral. We'll lock this, and then it goes to the next pin 2. Slide this out properly. Insert this. Insert this here, and insert this one also, and then lock it. When it is locked, take this one also, and then insert this one also, and then lock it. When you lock it, you bring this one, you can pass it through here, but of course it is coming to this our neutral bar. So we're going to lock this one here. So when this is done, the next thing to do is we're going to take from common and normally open, which is common and normally open, pin 8 and pin 6. So we're now going to take pin 6. Let's start from pin 6 of this one. It's going to go to pin 8 of this one. Okay, so this can settle here. So we're going to take pin 6 of this one. Let me get something a bit longer. So pin 6 of this one, I'm going to take it to pin 8 of this one. All right. And then of course, our A1 of this contactor, the A1 of this contactor, we're going to connect it to our L1. Okay, we're going to come here. We're going to come to this L1. This is our L1. So we can just take it here. And then we lock it. And then the A2 of this one, I'm going to use a long wire. I'm going to use something like this. Not really. Can connect the A2 from here, slap it out, insert, and then lock it. So instead of going straight to the neutral, it's going to come to pin 6 of this one. It's going to come to pin 6 of this one. And then the last one, we're going to take it. Yeah, I can use this wire. We're now going to take it from pin 8 of this one. Insert it here. This is our pin 8. And then to our neutral. Let me just pass this again from underneath. Alright, it's going to come back here to our neutral bar. And then we lock it this way. Okay? So the next thing to do is to insert our relays. This one goes here. This one goes here. Here we are not expecting any form of delay, so it's just direct. Then we'll have an issue with this one. Okay, this one goes here, and this one goes here. Right. So if we put on this one, this relay has made. All right. You can hear the sound. This guy cannot come on. If you put on this one, you can hear the relay. Then if you put on this one, you see our contactor has closed. So if any of this fails, this contactor will be de-energized. If any of this fails, this contactor will be de-energized. So this contactor can only be energized when all these three phases are complete. All right. So with this one is the representation of our phase failure device. So if you like this video, please let me know in the comment section. Share with your friends, and of course, please stay connected with me for more tips on power. Thank you very much.